Hey everybody, this video is one that's been requested by quite a few people. So if you know my Emmaselle 2, it's a very large electric airplane I designed myself, and I had put a dummy radial in the front of it because it's an electric. I mean, it's a 10 horsepower electric airplane with a 188-inch wingspan. You can see some of the stats on the screen right now. And one of the reasons I did the 3D printed radial in the front is because the plane needed some ballast in the nose. Every plane I design, I try to very meticulously figure out where the CG is going to be and how much ballast I need, if I need ballast. So I knew I needed ballast. But one of the things I wanted to do was make a really super realistic airplane. So if you remember, I basically put the single row radial engine on the front of it. And it, everybody said it looked great, and I think it looked great, but I always wanted to have a two-row. I always wanted a fake 18-cylinder engine in the front. So what I did was I started looking at how I had designed the whole front end of the airplane from the Firewall forward, okay? And one of the things that was important to me is how I get my batteries in there, how I get my ESC in there, how everything's cooled. There's an awful lot that goes on under that cowling when you have an electric this big. Now look, I know I get a lot of hate mail from people saying I should have put a real radial in this, and I'm an electric guy, okay, and I'm not a radial guy. I'm not a real radial guy. I'm electric. I'm 100% electric. I'm not against turbine. I'm not against anything else. It's just my fetish is electric airplanes, okay? So what I decided to do was I designed in Fusion 360 a two-row radial that I could 3D print, but I needed to really make sure that everything fit under that cowling perfect. So what I did originally was I designed a firewall. I designed basically a motor mount, which I got a bunch of hate mail about, and then I designed the radial, okay? So let's start first with the motor mount. Just so you know, I've got 1.5 years of flying on this two-row radial, this fake one, in this motor mount, okay? But the hate mail came out saying that the torsion or the torque loads would twist this around and it would ruin it. Well, clearly they don't know 4130 chromoly. Clearly they don't know TIG welding. They don't understand the forces, and that's fine. But someone seems like they always think that they're smarter than other people. But I knew what I was doing, and it's worked fine. So please don't send me things saying that this won't work, because it's been working for over 75 flights, and there are no cracks in any of the welds yet. So I had to design the motor mount. Then I had to design an adapter ring that the excuse me, that the 3D printed radial would attach to. And if you look at the back here, and something I want you to look at is the back of the engine. And later on, we're going to kind of dissect this a little bit. But if you look at the the two-row radial right there, the way it's sitting against the motor mount and everything, I want you to pay attention to where I just circled there, okay? Because later on, I'm going to tell you a story that I think is really, really cool, and it's just really, really slick. So basically, I needed to build this. So I could put my motor on it, put my adapters, and it would end up looking like this. So I welded up the entire motor mount with basically 4130 chromoly steel on my TIG welder. And I did make the front of the motor mount telescopic, so I could get my hacker to fit perfectly in that cowling. I didn't know if I could get the math perfect, so I wanted that to slide in and out. 440 screws go through each of those tubings there, and it works slicker than snot. So I needed to build a new firewall, and you'll see in a minute that I cut the whole firewall off the Emmaselle 2. So basically what I did was I took 1/8-inch birch plywood from aircraft spruce, and I fiberglassed one side of it, and then made sure everything was going to be lined up right on the, that my motor mount clearly would fit on all the parts. So here it is glassed on one side. Then I rechecked to make sure everything fit right. And then I cut off a perfect circle. So the front side of this is glassed right now with 1/2 ounce cloth, or 0.9 ounce cloth, and the West System epoxy. But I flip it over, and then I'm going to mount these hard points, because these hard points are what the actual motor mount connects to, because I'm using blind nuts. I'm using 632 blind nuts to hold the motor mount to the firewall. So it ended up looking like this, and then I glassed this with the 1.9 or yeah, it's 1.75 or 1.9. I can't remember what the glass cloth is. And this is what it looks like. You can see where my hard points are. I've already put the blind nuts on the back side of it. And then once I painted it, that's what my firewall looks like. So that turned out just, again, slick as snot. Then I cut off the entire front of the Emmaselle, which I've done twice now, and needed to put blind nuts for 440s all the way around the perimeter of this so that the firewall would be attached like this. Again, I got a bunch of haters, emailing me saying there's no way that firewall is going to stay on. Look, the tension strength of a 440 and a blind nut is insane. Okay, and as you can see, I've got a ton of them on this. So then I put the motor mount on. You can see the very front part of the actual motor backplate mount is not on there, and it telescopes in and out of those tubes. Then that's it painted up. And then I wanted to put the crankcase on and make sure everything just kind of fit. This was a trial fit right now, okay? And I had actually printed two different crankcases because my first one is going to have dummy bolts on it, but I liked putting these 256 studs on it, and they would actually hold the cylinders on. Okay, so here's my setup with the battery tray in there. The battery tray I made, basically I made, took 2 layers of 0.75 cloth and put it on a piece of plexiglass so I could peel it off. Then I took the honeycombing and put it on each side, sandwiched it. And then I put micro balloons around the outside edge. So that's my battery tray. Then I've mounted my ESC there. Keep in mind the ESC has to be in the flow of air. And then that's basically the way the motor mount, and the ESC looked. Then I'm going to talk a little bit about 3D printing. The crankcase in the upper left-hand corner is just the raw 3D print. In the bottom right-hand corner is where I use my acetone vapor bath on the ABS, and it melts the outside. I would recommend nobody ever do it unless you've highly researched it, because if you do it wrong, you can blow up your house. Anytime you turn acetone into a vapor, it's extremely explosive. I figured out how to do it. I've done it for 4 years now, without a single problem, knock on wood. And that's how you smooth it. And then when you paint it, that's what it looks like. But it didn't end up that silver. I didn't like the silver because the real crankcase, like some of the, I think R2800, whatever the 18 cylinder engines are, is gray. So it ended up being painted gray. This was the print of all the parts. Those little rings at the bottom didn't get used. Those were dummy bolt heads, and I ended up using studs. So the cylinders, the rocker covers, and the crankcase, and the adapter ring, the red thing, is everything I used on this. It took me about 2 weeks with my 2 printers to print this. Keep in mind the diameter of this thing's 17 or 18 inches diameter. It's a big-ass 3D printed radial. So that gives you an idea how big each cylinder is. And then I started trial fitting more of the cylinders on and making sure just everything aligned. And it just turned out slicker than snot. I mean, it really is neat. And this is me putting on more cylinders. I have the back row on now, put the front row on. So there's my 2 rows. But keep in mind, I 3D printed an exhaust. And for that exhaust, for those stacks to hit exactly where the exhaust port is on those heads, was a big risk. That means every one of my cylinders had to be perfectly mounted. Okay, so this is looking at it from the back, and then this is the parts I made for my exhaust, and that's my exhaust accumulator ring, and that was it being trial fitted on the rear cylinders first, which they absolutely lined up. I was really just thinking, okay, the back ones lined up great, but are the front ones? Well, the front ones lined up perfect too. So that's my 2-row radial with the exhaust collector. And then these pipes, now I needed to make these so you could take them, put them together and take them apart, not make them permanent, because I put LEDs in these. So a friend of mine and I designed a system that makes each of those ports kind of flash like the exhaust is firing. My friend Berger designed the computer circuit that did it, that does the flashing. And then I 3D printed all the parts to make the LEDs work. This is another picture. If you notice, the inside exhaust stacks have aluminum tape, and that aluminum tape helps the reflection of the exhaust. This is what it looks like with the cowling on. This is the front with the cowling on. This is what it looks like mounted on the plane with the battery tray, with the little edge around the battery tray. And there's actually a lot of Velcro on there that keeps my batteries, plus straps that go over the batteries to keep anything from moving. And that's what it looked like basically finished. And I love this beauty shot right here. This is from a drone flying backwards in the air in front of my airplane, and it looks really cool seeing that engine in there. And this is a picture of the drone flying up against the bottom of my airplane and picking up my exhaust pipes firing. And they all flicker at basically a made-up firing order. Okay, but now I want to get back to where I talked about the back of the crankcase. If you notice, there's nowhere for air to go. So I have a Hacker A100 in there, about 6,000 watts it's pulling, and that's a lot of heat. And I was really scratching my head on how to get the heat out of there. And I came up with an idea, and again, the naysayers say, well, you'll never get enough through there to make it work. And basically, if you look at the cylinder, you don't realize the back of the cylinder is open right now. That 3D printed cylinder right there, that Fusion 360 picture of those heads actually have, those cylinders have grooves in the back. So if you look at it like this, you can see those grooves. Originally, I tried to 3D print them, and it just took too much time. Too much support was needed to do this right. So I actually took my bandsaw and opened up the back of the cylinders. From the front, you can't even see it. From a 45-degree angle, you can't even see it. So basically what happens is if you look at this, on the upper left-hand corner is the back row with the vents cut, and you can see right through it. On the bottom right-hand, you can see it. Now, I don't have the front half of the cylinders on, but that's how much opening there was for air to come through the inside of that engine. So basically, as the air comes into the front of the Hacker has its own fan on it that's blowing all the heat out the back, and all that heat, if it's from the outside of the motor canister, radiant heat, it's going to come out the first row of cylinders. The second row of cylinders is where the most heat came out. And believe it or not, my engine runs cooler with this setup than it did the single row. So it absolutely works because I can, I measure the temperature of my plane, of my motor. So basically when it was done, it worked out perfect. So I know I had a lot of people asking me how I did this and what it looked like. I wanted to do a little bit deeper dive, and it just worked out perfect. I mean, I'm not sure what else I can say. If you got any questions, of course, email me or ask through YouTube. If you haven't subscribed to follow me, do it. I'm going to be doing at least one video a week now. And please like my videos because it helps me with the YouTube algorithm. And I'll see you next time, everybody. We're going to take a deeper dive into the actual design of the Emmaselle 2 in the next video. I'm going to talk about how I did the spars, how I did the wings, how I did the fuselage. We're going to dive in a lot deeper on how I really designed the Emmaselle 2. So have a rocking day, everybody. Be safe and take care. Bye.